This is the simple version of page 2. I'm going to keep this one simple. Rambled on the last one. So, how's velocity different from speed? Speed is how fast. Velocity tells you not only how fast, but also the direction. Speed and direction. Done. The next one, which graph shows accelerated motion? These are distance versus time graphs. If you remember from doing the motion sensor thing, anytime you accelerated, you got a curve. If you speed up, it kind of goes like this. If you slow down, it goes like that. If you stay at the same speed, it's just a straight line. So this is the one with the curve. That's got to show you accelerated motion. That's going to be B. Now, how can you tell? I do want a pretty good answer here. Please, I might give you partial credit if you just say this one curves. But why does the curve show that it's got acceleration? And I think this is a good answer for that. Curve B shows that as time goes by, a greater distance is traveled during each second. So I'm just going to, I'll read it. For example, less than 1 meter is traveled in the first 2 seconds, 4 meters were traveled in the last 2 seconds. So from here to here, during this time, you can see distance-wise, it just goes from there to there. So only this tiny little distance from here to here. During the last 2 seconds, from 8 to 10 seconds, it's going from 4 meter mark to the 0 meter mark. So this much distance. So this one clearly shows that the distance being traveled per second is increasing. So that means the speed is increasing. And if speed is increasing, then velocity is changing. And that's acceleration. All right, now I'm going to try to make this simpler this time. We've got to match these distance versus time graphs. These are like the ones you would make if you're walking in front of the sensor. We'll match them to a velocity graph and we'll match them to an acceleration graph. So let's see. I'm going to write a few things here. Up equals positive / away. Straight line equals constant speed or velocity. And curve equals acceleration. These are all things that you saw when you did this. When you walk, this is somebody walking away from the sensor, which is like positive. Positive motion is away from the sensor. You're gaining distance. So here we go. Straight line. That means the velocity is not changing. This is constant velocity. It's walking away from the sensor, so it's positive. So we're looking for a velocity graph that's constant, meaning the same velocity, and positive. This is the one. It's up in the positive area, and it doesn't change. Now, since the velocity is constant, we know there's no acceleration. Acceleration, it would be a curve. So we look for the acceleration graph that is nothing. And that's this one. There's no acceleration the whole time. So let's see. Now here, this was the one that was so much trouble, but let's just follow these little clues here. It's curved, and it's going down. So since it's curved, we know there is acceleration. It's curving downward, so that's deceleration. That's negative acceleration. It's also going downward, which means we've got negative velocity. So I could do them in any order. Velocity graph, since this is going downhill, we're looking for a negative velocity and a negative velocity that's changing. So we've got two with negative velocities, but here the negative velocity is staying the same. Here the negative velocity is changing. So that's A. Now the acceleration graph, it's going to be one that is accelerating and it's curving down. It's not curving up would be like this. This is curving down. So we're looking for a negative acceleration. That's this one. Here we've got one that's going downhill, so the velocity is negative. It's straight, so the velocity is constant. So we're looking for this. This is same velocity the whole time, so constant velocity, and it's a negative velocity. If the velocity is constant and there's no curve, there's no acceleration, so we got C again. Last one, it's curving up. That means it's speeding up, so we've got an acceleration. I'll go ahead and do this. Positive acceleration. And if there's positive acceleration, we should see velocity going up at a constant rate. The only one of these where velocity is going up is this one. That's it. A little shorter than the other one.